Alright, in this video we will learn how to graph linear inequalities, and what's nice about this is you pretty much already know how to do it. You know how to graph things in slope-intercept form. It's really almost the same thing. So our first step, as it says here, is we're going to change these into slope-intercept form. It's usually easier to graph things when they're in that form. And then we only have to do two extra things besides that. First of all, we have to decide if the line that we're graphing is going to be solid or dotted. And how do you tell the difference? You use a solid line if and when you have y is greater than equal to or y is less than or equal to. And the reason it's solid is you want to show that it could actually equal that line. That's what this equal sign means. And that's how we indicate that by using a solid line. A dotted line is used if it's only y is greater than or only y is less than. The reason you use a dotted line is you want to symbolize or represent that y gets very close to that line, but it never actually touches it, never equals that. And so that's how we signify that. And then the second thing is we have to decide whether to shade above or shade below that line. So let's, for example, say we had a graph right here, and it was this red line, and somehow the equation was y is greater than something. Well, greater than means you would be shading right there. You'd be shading above the line, because the difference between an inequality and an equation is this. If I have an equation, let's say x plus 3 equals 5 versus x plus 3 is less than 5, the answer to this is x equals 2. The answer to this is x is less than 2, and that means there's any number of things that x could equal. X could equal 1, 0, -1, -2. There's an infinite number of things that x could equal. So in order to symbolize that on a graph, the way that we do that is we do this type of shading right here. So see if you can pause the video and try and do those three things. First of all, change it to slope-intercept form and graph it, because we've done that before. And then decide if you want to have a solid dotted line and shade above or shade below. Alright, so let's start by changing this into slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And don't worry so much, you might say, well, equals, neither of these have equals, they have these inequality signs. That's okay. We would just change it to y is greater than or y is less than mx plus b. So the first thing we need to do is move this over, because the slope-intercept form has just y equals and there's nothing beside the y. So we'll be left with 5y is greater than or equal to negative 2x minus 15. And it doesn't matter, we could have written that as negative 15 minus 2x. I wrote the negative 2x in front because that's how they do it in slope-intercept form. Alright, the other thing about slope-intercept form, it's y equals, it's not 5y equals. So we're going to solve that problem by dividing everything here by 5. And we'll get this, y is greater than or equal to negative 2/5 x. 15 over 5 is 3. So there's our equation. We had to graph this with the y-intercept at negative 3, and the slope is minus 2 over 5. So go down 1, 2, go over 1, 2, 3, 4, 5. Or we could go up 2 and to the left 5, which would be here. Alright, so we've taken care of this first step. Second question, is this going to be solid or dotted? Let's say that 3 times fast. It's a tongue twister. Solid or dotted line? And the answer is based on this. It's greater than or equal to. And the fact that it could be equal to means that we will put a solid line, because that shows you that y could actually equal that thing right there. Alright, and then the last thing is to decide whether it's shade above or below. So I'm going to call this stuff above the line region A. I'm going to call this stuff below region B. And my question for you is, based on this right here, let me put it in green so we can see it, based on this, what does that say? It says y is greater than that negative 2/5 x minus 3 line. Y is greater than. So think about this for a sec. Which region, region A or region B, which region is y being greater than that line? And hopefully you'll be able to tell me that it's going to be this one right here. This is the region where y is greater than. So we'll shade right above there, and that's exactly how we'll graph it. Alright, if you haven't tried it, see if you could try number 2. It's going to be the same exact type of procedure. Okay, this one has a slight twist to it, which I'll show you. So let's start by changing it to slope-intercept. We'll subtract the 6x, and we have, let me write it up here, we have negative 5y is less than negative 6x plus 15. Here's the slight twist that I mentioned. Okay, and it's only a slight one. We need to solve for y by dividing by negative 5, and here's what we have to remember. When we multiply or divide an inequality by a negative number, this sign flips directions. So this is now going to be y is greater than negative 6 over negative 5 is positive 6/5, and then 15 divided by negative 5 is negative 3. So that is our line. We have a y-intercept at negative 3, and then we're going to go up 6 and over 5. Or again, we could go down 6 to the left 5, but I'll keep it right there because going down 6, we'd go off that graph right there that we have. All right, now the next question is solid or dotted line, and based on the fact that this is a should be looking at this one, y is greater than, y doesn't actually equal that, it's just greater than. So we'll symbolize that with a dotted line to show that y doesn't actually reach that line, it just gets pretty close. Okay, final question asked, let's call this region A, we'll call this region B. Which region has this being true, or y is greater than? And you might have played that arcade game Pac-Man where they say, Pac-Man always eats the bigger number, so that's why I'm saying y is greater than, because the sign is opening towards the y. So y is greater than, and greater than means we're going to shade up here in region A where it's above the line. So that is how we graph linear inequalities. Hopefully that makes some sense.